Today, we're going to head down to southern France, where a legendary monster is getting ready for one of the greatest technological quests humanity has ever attempted, building the future of clean energy. So, picture this. Inside this massive industrial hall, there's this bright yellow behemoth, just waiting. And trust me, it's a monster by any definition, and it's about to take on a job of truly epic scale. But here's the twist. This isn't some creature feature about destruction. This monster is a builder. Its entire mission is to help create something our world has literally never seen before. So the big question is, what on earth is it building? All right, it's time to meet our monster. And no, it's not a creature from a movie, but it is an absolute marvel of modern engineering. Everybody, meet Godzilla. I mean, just look at these specs. It's 4 meters tall, its arm can reach out 5 meters, and it can lift over 2 metric tons. Yeah, with numbers like that, you can see why it got the nickname. Officially, though, it's the most powerful commercial industrial robot on the entire planet. But Godzilla isn't just here to flex its muscles. It has one single monumental purpose: to get everything ready for the assembly of ITER, that's the International Thermonuclear Experimental Reactor. It's basically a global project to build an artificial sun right here on Earth. And to really get why a robot like Godzilla is so critical, we first have to understand the incredible science that it's serving. So let's talk about what it actually takes to build a sun on Earth. It all comes down to this one process: nuclear fusion. This is the exact same thing that's happening in the core of our sun. You take light atoms like hydrogen, you heat them up to, just about 150 million degrees Celsius, and then you smash them together. And the result? A massive release of completely clean energy. Now this is why everyone calls fusion the holy grail of clean energy. See, unlike nuclear fission, which splits heavy, dangerous atoms, fusion joins light ones. The fuel for it comes from seawater, so it's incredibly abundant. And the waste? It's minimal and doesn't stick around for thousands of years. But the big one, the most important one, is safety. With fusion, a meltdown is physically impossible. And the energy potential? It is absolutely staggering. To put it in perspective, get this. Just 1 kilogram of fusion fuel can produce the same amount of energy as 10 million kilograms of fossil fuels. The promise here is just almost limitless. But, and it's a big but, trying to harness that power means we have to build one of the most complex machines ever designed. I mean, it is a task so daunting that a lot of people have called it an impossible assembly job. I absolutely love this description from the engineers working on the project. They call the reactor core a steel onion, because that's what it is. It's made of thousands of unique components, all layered on top of each other, and every single part has to be installed with millimeter-perfect accuracy. There is zero room for error. So you might be thinking, why not just send in a team of really skilled people? Well, because you can't. It's just flat out impossible. The space is way too tight, some of the parts weigh over 4 tons, and the precision needed is way beyond what human hands can do. And that's not even mentioning that the inside of this thing has to be cleaner than an operating room and will eventually become radioactive. So the solution is this really innovative strategy called rolling waves. So instead of building one layer, then the next, multiple robots are going to work at the same time in these continuous overlapping waves. It's going to be a nonstop 2-year-long robotic symphony. And this brings us right back to our star performer. Because to get ready for a symphony like that, you need a very, very special kind of robot. It isn't just about raw power. It's about having a delicate touch. This chart really shows you why Godzilla is such a big deal. A normal factory robot, it's basically blind. It just follows a program. If it bumps into something, it just keeps on pushing, which in this case would be catastrophic. But Godzilla is different. It can see, it can adapt, and it can even feel its way through a job. So what are its superpowers? Well, for one, it's got integrated vision, so it can see its targets. Then it has these force sensors that basically give it a mechanical sense of touch. Like when you're gently pushing something fragile into place, you can feel that exact moment it makes contact. That's what these sensors do for Godzilla, so it doesn't damage these billion-dollar parts. Oh, and it can switch between more than 30 different tools all by itself. Now here's a really key point. Godzilla isn't actually going to be doing the final assembly. Its job is arguably even more important. It's the star of the dress rehearsal. It's testing every single tool and every single procedure to make absolutely sure the actual assembly robots get it perfect when it's showtime. All of this incredible engineering, it's all serving a much bigger purpose. All of this work is laser-focused on one ultimate goal: powering our future. Now, this is a long-term vision. ITER is hoping to achieve what they call first plasma. That's the initial moment of fusion, sometime in the 2030s. That success will then pave the way for a prototype power plant in the 2040s. And if everything goes according to plan, we could see the first commercial fusion plants powering our cities by the middle of this century. And the payoff for all this effort? It is nothing short of world-changing. We're talking about truly clean, carbon-free energy. Fuel that's basically inexhaustible. A constant, reliable power source that's also completely safe. That is what success looks like. Of course, we have to be realistic here. This is one of the most difficult things humanity has ever tried to build. The road ahead is absolutely filled with challenges, from massive costs to inventing new materials that can withstand the heat, to perfecting the fuel cycle itself. You know, for decades, fusion power has famously been just 30 years away. But when you see a robot with the strength of a monster and the delicate touch of a surgeon practicing how to build a star, it really makes you wonder, is this what it looks like when the future finally starts to become the present?